Good morning. At least well-deserved. Congratulations. I'm Clay Morey. I'm chairman of the Industry Relations Committee. We're getting ready for this morning's plenary session. If I could ask my speakers, Anka and Karen and Robbie, to come up on stage. We'll get going in just a minute here. Okay, thank you and good morning again. Getting a little bit here just set up for the technology. We will have the ability for the panel to ask some questions with Slido, so I'll be able to see them here and then we can put them up on screen afterwards, so hope to engage. Well, thank you for joining us this morning for this great panel session. Really it's wonderful to be back in person. With actual people on stage as opposed to all the virtual events I've been doing over the past 2 years. It's nice to see people's faces, and thank you all for showing up this morning. I know it was a bit early this morning to come for the award, but appreciate it. I guess Dubai doesn't get up as early as maybe, they go later and they don't get up as early. So, this is about small satellites solving climate change, and I think we all know this is the #1 topic, I think, in the world today. I mean, if you're paying attention at all, climate change is the #1 issue that we're talking about. And really, I think if you look at COP21, and now we're 6 years removed, I think, from COP21, where we've come on this topic to be at the forefront. And we like to say in the space industry that we're going to space to benefit life here on Earth. Really, we're utilizing space to help planet Earth, to help humankind. And it's maybe a topic that the general public doesn't see as well as us in the industry. We see it. We're trying to carry this message back, let's say, to the general population, but maybe it's not as well understood as we would like it to be. But I really am looking forward to this discussion because in parallel to this topic of climate change, we have the revolution in small satellites. And Robbie's company, Planet, here is one of the leaders in this revolution in small satellites and using small satellites and the applications and the data that they provide to really analyze and help us to better understand what's happening in climate and lots of other areas as well, not only climate. We'd like to have a conversation this morning, more than just a set of presentations. I've asked the panelists to give me some questions, but we are also going to be interested in having the audience as well participate with questions. So with that, thank you for the lights. Without further ado, Anka is the chairwoman of the German Aerospace Center, the DLR. Anka, maybe you could start by talking a little bit about DLR and DLR's role in research and development. How is what you've done investing in research and development worked on this topic to format change and to be able to analyze climate change?
Yes, thank you. DLR has been working on Earth observation for quite a long time actually, and small satellites become increasingly important, and that's because these small satellites really complement the larger satellite missions, and we believe that DLR has unique expertise in a number of fields. that you really need to be successful with small satellites. So we have done, of course, design. We have looked into components, into assembly, into systems, and of course all that together with industry. Of course, industry in Europe, but beyond. And we think that small-scale satellites and Earth observation are an ideal complement, actually, because they are smaller, they're cheaper, they can tackle special issues, and they allow you really to look into things in much more detail and much faster. And that becomes increasingly important, not only for the big Earth models, but also for regional climate models, where you have very specific needs. So, for instance, coastal regions or regions with fires, which currently occur. So, there's a number of things where the small-scale satellites can be just a lot quicker and a lot more in detail.
Thank you. Karen Sinterman's with us from NASA. Karen, I don't know that NASA gets recognized maybe as much as it should for having an impact in this area. I mean, it's always about exploration and human spaceflight, but really NASA's done a lot on this topic on climate change. Maybe you can tell us a little bit about what's happening there.
Sure, thank you so much. I think you're right. I think many people don't understand that space-based observations underpin much of what we understand today about climate change. And today, NASA has a fleet of 23 different satellites, and I don't know if we've got the graphics we can queue up, but
do we have the images in the back we could put up?
Anyway,
okay.
So we have today 23 satellites orbiting the Earth, looking at the atmosphere, there you go, the oceans, the solid Earth, and we have about another dozen up on tap for launch in the next couple of years. And these observations have largely settled the major questions of climate change. But I think what's ahead of us is questions about exactly how climate change is going to play out regionally. And that's really where we're going next. These observations, they underpin our ability to understand. And of course, when you can understand, you can model. And when you can model, you can predict. And I think we like to try to tell the story of the role of observations in underpinning that planning going forward. Thanks.
Thank you. Maybe if we put the giant names of the satellites in space so people could see on the ground, they'd understand a bit better. Just joking. Robbie Shingler. Robbie is the Chief Strategy Officer at Planet, really a mission-driven company in this area. Can you talk about that? How is that to be a company whose mission is to better understand planet Earth and small satellites?
Sure. So as Karen said, 23 satellites up in space, and I grew up at NASA, building small spacecraft and working in the Science Mission Directorate. And about 10 years ago, we saw that there was a potential to shrink the satellite, mass manufacture them, and then use automation and AI to have an order of magnitude more satellites in space. And that is to get to frequency and frequent updates of our planet. Much of the Earth observation satellites that are in space are to understand our changing planet. And this has been pioneered by NASA and by ESA for the last 50 years. It is also up there for national security purposes. So there are many more satellites that are up in space for reconnaissance and military and intelligence applications. And I think what is happening today is a recognition that all of those satellites need to have data that is interoperable, because there are many more applications for our home planet, for combining those data sets together to then put them into an operational workflow, as Karen was saying, for modeling what's about to happen, so that we, as individuals in our communities, as business leaders, as government leaders, can understand context and make better decisions. To your question about the planet, we are an Earth observation company started about 10 years ago with really from the space community, but over the last 10 years we turned it into a data business and wanted to build a company that is part of the overall ecosystem to activate new data to allow for us to make better decisions, to become better stewards of the planet. And we did that as a commercial company, but we have a mission at the core. And our business model is wrapped around our theory of change, which is that with greater transparency, we make better decisions. So as a mission-driven business, I think there are a number of trends that are happening in our society where it's deep partnerships with governments, with civil society, and with commercial companies that have a shared vision and mission where each play their role in the most efficient way possible that allow for us to then better steward and take care of the planet. So we chose to do it as a commercial company, but it is a mission at the core of our business.
That's wonderful. Let me just pull on that for a second, though. You mentioned, so we all think of ourselves as being involved in the space industry or space agencies, but you really talked about being a data company. I know you guys originally based in San Francisco and Silicon Valley area, but you have folks here in Europe as well. But for the agencies as well, like how do you transform from being satellite platform in space to really actually being a data-driven enterprise or a data-driven agency where you're trying to figure out how to take this vast amount of ones and zeros and translate it into something that's usable or something that you can use to learn? Anyone want to take that one? I know that's probably a big question.
Yeah, thanks for asking that question, and we really value the partnership with our international agencies and our private sector entities that are in this challenge with us. We actually had a terrific conversation about this topic last night in this room on what we're calling open source science. The idea is, in addition to the small satellite revolution that we're talking about here today, we also have a revolution going on in analytic techniques and in open platforms and cloud-based computing. All of that really sets the stage for what we're calling this open source science, which is to bring the data, the analytic tools, the compute power, all out into the open to accelerate, to meet the demand, to accelerate the pace of discovery, and also the transition of that knowledge out into the world of users out there who would like to apply it to their decision making, just as Roddy said.
So open source meaning everyone has access to this vast amount of data that NASA and I guess NOAA probably has. Yeah.
Absolutely, and it's building on the principles of open source software development. The idea is that all of the code, the documentation, the data, that's all openly available, and you create almost a beehive of activity to propel the discovery and the applications forward. So we think that principle is really what's going to allow us to more fully exploit not just the government satellite data, but the private sector data as well.
Yeah, actually I think that the whole data also plays a very important role in calibrating the climate models and then also in the verification actually. So it's not like climate models are perfect. And so and there's always also the question of the more global models and the more local models and how to get those really to interact with each other as best possible. So the whole data from space observation combined with even other data from Earth observation by other means, say by aeronautics or by other observation methods, all that needs to come together to build the best possible models. Because only with the best possible models it will be really possible to predict the future for the global Earth, but also for the regions, and that becomes more and more important in mediating also the climate crisis. It's not just necessary to observe it, but it's necessary to mediate it and also to find out if those mediation measures are really the right ones. So I think the number of years we're going to need this Earth observation data. It's going to be infinite, actually. And we need all the data we can get.
Yeah, I think that shift in our community of thinking about why we're going to space robotically is really to either collect unique information or transmit information. And whether it's weather satellites or Earth observation satellites, early warning systems, reconnaissance satellites, navigation satellites, that is transmitting unique information and comms. And what has in our community, just like any other industry, it's being digitized. And Earth observation is now becoming more of a cloud-native ecosystem, where it isn't just about the picture, one picture that you collect, but it's a virtual, deep stack of information that you can then query through and against. Open source is really about also open standards. Data to become interoperable. Open source software, if you build them in little building blocks, then governments and companies and communities can take those building blocks to then develop their own sense-making application for something that means something to them. What it means for us in the space community is we need to be thinking about interoperability of our data systems and what we're missing as a broader community in observations. Whether it is more frequent information or somewhere else in the electromagnetic spectrum. All of the different satellites that are up in space really have a unique mission, but it's one puzzle piece of a complete picture. And so we need to think about this a little bit more as a virtual constellation of interoperability, collecting that data, activating it, and then building really good indices, indicators, and all driven by machine learning and models that allow for us to better understand facts on the planet in near real time.
Can I drill down on that you guys talking about the open data sets? Do you guys have special sauce in terms of how you look at your data? Is all of this data accessible? And I'm not the computer scientist here, but can you take all that data in the same types of sets and manipulate it, or is it really have different languages to speak to different data sets? Does that make sense?
Yeah, I can take a stab at it first. So, I'm a space person. That's how I actually came to this. The insight with Chris, who's here, and Will, our third founder, was that we can do frequent observations of the planet because change is happening so quickly. That was the insight, but we came at it from space. It was really a shock to me as we were building our business to understand the industry of remote sensing is really it didn't find the internet yet, and it didn't find the cloud. And so we had to really rethink how to process all of that data from a cloud-native architecture. And that's been a tough challenge, and it's a never-ending challenge. But just like any industry that has an ecosystem, there are standards that emerge by the actors that are solving hard problems. And so a couple of good standards have come out over the last few years, and this has been with NASA and USGS, and this has been with the European Space Agency through the Open Geospatial Consortium, a nonprofit called OGC, that make these standards for information to be optimized for the cloud, and information to then be easily searchable so that everyone can put it in a common format. We're just at the beginnings of this. If we back up for a second and we think about the internet, right, which transformed businesses all through the 90s and 2000s, the history of that was much earlier, which came out of a defense application and then went into academia. And then it was actually, a nonprofit for ICANN and the IETF, the Internet Engineering Task Force, where the actors, both in military and in emerging industry and hobbyists, as well as in academia, got together for standards. When you have standards and interoperability, then there becomes a greater participation architecture for people to play and collaborate together, and that's where innovation can come from. The barrier to adoption and innovation comes down And then new businesses can be actually created, or new products and services that can be created on top of that. And I think that there's a similar thing that's happening in Earth observation. Because the societal benefit of understanding what's happening on our planet is critically needed, and we kind of take it for granted, but the rest of the world doesn't know that yet. You have to be a remote sensing scientist to extract the value out of all of this data that we're collecting from space as a community. But to really get to the societal transformation that's needed to transition our economy to a more sustainable economy and really understand risk on our planet is for developers to have access to it and business analysts to have access to this information. And that's really the challenge of our ecosystem and community today, is to go further up the value chain to then allow for new entrants to come in who don't know anything about space. And they don't know anything about remote sensing, but they can get these data feeds and then actually use that to have societal benefit.
And actually, there's also the point that you also have a large amount of data which has been collected every year. So for instance, we have an open archive, and you can look into that one, and you can see the changes in urbanization. You can see changes in climate, both natural and man-made. So that's, I think, a vast amount of information that even today needed to understand processes that have happened already, and to extrapolate from those to future processes, for instance, in other regions, or looking at, in fact, natural processes that also happen and that also have a strong influence on the habitat. So I think there's a vast amount also of what our predecessors have done, and which is also publicly available.
So let's talk about, we were talking about small satellites. There's also very big ones, right, that are up there. What's the difference? Where are satellites, small satellites fit? Is there a niche there? Or what can you do small that you can't do big or small? Or, what do you think, Karen?
Well, it's a great question, and I think there's room for all of these capabilities. In fact, they all have different. They all play different roles. But in particular, Robbie mentioned a couple of the benefits of small satellites, and I think when we first started talking about small satellites, the conversation was around affordability, disaggregation, graceful degradation, that kind of thing. But it's becoming a far more interesting and sophisticated conversation now, because we can start to do things with small satellites and even small constellations of small satellites that we could never do with large satellites or in the large instruments. Now, the opposite is also true. There will still always be things that we can do with the larger instruments that we can't do with the small satellites. But I'll give you a couple of examples. I'll give you one example in particular. We can now fly small constellations of small satellites in formation with small time gaps, from seconds to minutes to maybe hours, and actually examine processes in the environment in ways that we never could before, because we couldn't afford to make these kinds of observations with the larger systems. And that's allowing us to go after questions about how severe weather evolves, how wildfires evolve, those kinds of critical questions that play into our understanding of how climate change is going to affect communities locally and regionally around the world. Because when we talk about climate change, we often talk about 1.5 degree global average change in the temperature. But of course, that's not the way communities experience climate change. They experience it in drought, heat waves, severe precipitation events, and so forth. So getting to the understanding of those processes is something that I think small satellites is going to help us, or will help us unlock.
Robbie, you have from Doves, right? The smaller 3U form factor to something maybe yay big, SkySats.
Yeah.
What's the difference in capability between those two? platforms? Is there a huge difference?
Absolutely. So as Karen was saying, like it's no one instrument or one satellite that you can do. What we pioneered was in the 2010s. I would say two things happened in space that changed the equation of what's possible. One is reusable rockets, and we got to about 4x cheaper access to space. Then the second is rethinking about the satellite segment, where you have many of them, and so each one is decreased in performance. But then when you have dozens or hundreds of them, you come up with new missions and new observations that you haven't been done before. And the cost performance increase of that has been 4 orders of magnitude over the decade. So 4x cost decrease, 1,000x cost decrease in satellites if you take risk on a little bit differently. So that's quite profound. And so large satellites can become a reference frame for other satellites to then make it more interoperable. The community does that with Landsat. They do that, we used to do that with Hyperion, a hyperspectral satellite that was up in space. And we do that also with the Copernicus programs because we know that they're going to be there, right? These are digital public goods that that the public sector is making available for society. So it's a baseline of truth, and that is absolutely critical for then other sensors to come in to then calibrate against it and make it interoperable. And if you have that highly calibrated sensor, it's a big satellite. It's expensive. You can't do hundreds of them, but you can do singles of them. And so we really need to think about this as a virtual constellation. And all of the data needs to be about interoperability. But to your point around what small sats can do, as Karen was saying, you can fly them in formation. The thing that we ended up doing was building about 100 to 200 of these satellites in formation in one particular orbital plane that acts as a virtual line scanner for the planet to image the whole world every day. It lends itself to automation. You know, we have it's a lights out capability. It's just a sensor. It's just an IoT sensor that happens to be in space. And when you think about space satellites and infrastructure in a different way, then you can open up new mission opportunities.
Fantastic. Okay. We talked a little bit about this, but how about the speed at which we can now deploy small satellites can allow us to go faster? Are there companies in Germany that are working on this to deploy more quickly sensors technologies?
Yeah, actually, I think the small-scale satellites really, because of the miniaturization of the components of higher integration, they can be a lot faster built. They can be built a lot cheaper, and that means that due to the cost difference of the small satellites to the large ones, we also can access a different set of companies. So it makes it really possible also to SMEs to contribute. It makes it possible for slightly bigger companies to have a real impact, and it even makes it possible for the startups to enter the market. And we actually do believe that that's going to revolutionize what we can do. And that's going to create a market where we really should see completely new players in it. And that's something we try to encourage strongly. And our agency, therefore, has even actually had a competition. And we've seen that these competitions activate people and that they create also visibility. And we believe that these new smaller satellites also will have an impact in monitoring. That's something where, I mean, what we do think is that it also provides, actually, as you said, you can calibrate it against bigger ones. So it's going to be a means to really objectify and quantify emissions. And that's going to be interesting also of course, the governance, because it's a unique possibility to get real quantifiable data, and that's to not only put them into models, but also to find out whether they keep within the limit they're given. So I think that's also something which will become more and more interesting, and which will create more and more demand.
This idea of accessibility to space, Robbie, you touched on with reusable rockets and some of the new small launch systems that are coming out. My founder, Jeff Bezos, always talks about how can you get three college students or three guys in a dorm room to figure out how to launch the next company, right? If you don't have affordable access to space, if you don't have these small form factors where you can actually build and deploy something that you really put into space, really this is kind of the key, fundamental, and the interplay between launch and the small form factor.
I do want to mention one thing too about small satellites and the history of small satellites. It was really Surrey in the UK that really pioneered this a lot and got countries to be in space for the very first time. It was really there for a bit of a capacity building and training engineers around systems engineering and understanding what it takes in order to build these systems. And so really huge hats off to that. And I was a beneficiary of that in undergrad. I graduated over 20 years ago, but I worked on small satellites and it was for training purposes, right? Then I would say probably the next big thing that happened in small satellites was a German company, RapidEye, that had the insight, okay, if we can do 5 satellites, then we can do a monitoring mission for agriculture. And that was a really unique public-private partnership that was started in '99, and it took a long time, but they got the satellites built and they launched it in 2009. And excellent satellites started to do this monitoring program. And one of the challenges, though, is we are all in a shared global economy, and when something collapses, like in 2000 and 2001, then we have this implication. But like we all feel it. And that actually is something that inspired us at Planet. Not only was it our time working at NASA and space agencies, but also that mission of RapidEye. And that's what brought us to Europe, is we actually acquired RapidEye and got that knowledge and that archive of data and understanding remote sensing and then the globally distributed channel partners that are out there. And then we brought it to the cloud. And that really is, I think, what has transformed the economics of Earth observation for new businesses, is the fact that you can easily process data and extract the insights out of it. That's the game that our Earth observation community has to play over the next 3 to 5 years. We have to accelerate that because many more people in society need to have access to this information. But the history of small satellites is long, and it continues. But now the performance in a small package is super high, that you can actually come up with empirical measurements in something a couple hundred kilograms that our current way of thinking about these missions would be thousands of kilograms. And so that is, again, changing what is possible. And if it's smaller, it typically is cheaper and faster to do, which is typically cheaper so you can take more risk. So then you can then, as a space agency, have more missions so that you have more chances at doing these missions. So I see it as almost like a portfolio of higher risk, lower cost, and really exquisite, important programs that are higher cost that you know are going to work. And that really is the overall virtual constellation of what's happening in space today.
So mini but mighty, right? This is the. All right. So what should we be focusing on in terms of small satellites and climate change? What's the big topic these days? Where are we heading? Karen, I don't know if you want to try to tackle this one. I know there's a lot out there.
Sure. So I can talk for just a minute about where NASA is heading with the Earth System Observatory. And I don't know if we've got the second little video clip, we could start that. So NASA chooses its future missions with guidance from our national academies, which tee up what are those key questions? And of course, many of those are around climate change. So we're moving forward with the Earth System Observatory, which is a collection of missions, but we choose the name intentionally. We had this whole discussion earlier about open source science and using all the data together. So we'll have a number of missions, but we're treating them as one observatory. And they will be able to examine the atmosphere, the relationship between aerosols and clouds and precipitation, and even looking actually in partnership with ESA and likely DLR, looking at gravity change, which can tell us the condition of underground aquifers. And so a number of these missions, there'll be a mix of sizes, medium to small, generally. And we think this is going to give us the holistic picture of our Earth as a system, which is really how you need to look at the Earth to understand climate change. So this is where NASA is heading. And then if you pull up the second image there, layered on top of that core Earth System Observatory will be these Explorer missions. And again, these will all be competed. And I expect to see a lot of small satellite solutions against this set of observations as well. So there'll be, just as Robbie said, a nice mix of different kinds of capabilities that examine the entire Earth system, but moving all of the data out into a common ecosystem precisely to accelerate the discovery and the use of the insights we gain from these systems. So that's where we're headed, in deep partnership with our international space agencies as well as the private sector to pull this off. It's ambitious, but we think it's what we really need to do.
So at the risk of putting everybody to sleep, right, we talk about satellite procurement or data procurement. Space as a service, right, is what we talk about a lot now. And you hear this, whether it's launch or satellite capability. So commitment to buying space as a service, how do you see this? Are you buying platforms? Are you buying services? Are you buying data?
Yeah, right now we're doing all of the above. We're doing a lot of, we're learning, right, by trying. So we're buying access to space as a service. We will continue, I'm sure, to buy satellites themselves. But we're exploring all of these different business models and learning as we go. And I expect our industry partners are also learning as they go as well.
Absolutely. So Karen has been leading along with Thomas, trying to figure out that partnership and interplay between a commercial company and also the science community. And for the last 3 years, we have been working together on that, starting first with the pilot, where we uniquely, imaging the whole world every day, can come up with a license that has limited use. So then you can decrease the cost, so that we can then still have a commercial business model in other places, because there's so much scientific utility out of Earth observation data that's collected. And I think that we really worked together to figure out what that science license was. And it was hard on both sides, and we didn't get it perfect, but oh my God, is it now working, right? We just expanded it to then make it available to every U.S. government researcher and grantee, which is all of the whole world every day and the whole archive, 1,500 images deep of the planet over the last 5 years for scientific purposes. And now we're beginning to see a publication, I think it's about every 15 hours, by the science community, because we were able to figure out that license, then make the data available to researchers, where they can then do that kind of that discovery science, instead of thinking about it from first principles and needing to design an instrument and then needing to collect the data. Is almost like, well, what can you do now with daily data? What can you do with tiered observations? And so there's such innovation that's coming out of that, and I think that it's a great example of a partnership where we have aligned interests to figure it out together, and forging new ground that then makes it available for other companies that also have data that has scientific utility to then follow along. So that's a deep partnership that I think has worked really quite well.
Anka, what's DLR working on? What's next? What's coming? What's the future for you guys in small satellites and climate?
Yeah, actually, I think that fits quite well into that picture of the ecosystem, and I think as Karen already said, there's aspect Earth observation laboratory. Of course, there are quite similar activities by ESA, and as we already all said, the big satellites are going to give you really the calibration, and the smaller ones will be the satellites you can use for special purposes. And I believe you have a mission coming up about methane and the global methane production, and what we are going to look at is something which is complementary. Our next mission we have planned, in fact, for small satellites, and that one is going to look at the CO2 emissions and complementary to the ESA mission. This one is going to look into much more detail. So we are going to aim for a spatial resolution of something like 50 meters by 50 meters, looking at point sources. So that will enable us to really quantify CO2 emissions by various manufacturing plants and other things quite well. And that will be a large step in really controlling and monitoring and also in the control of emissions. And we believe that that's a quite special application, but that would be the one I would want to point out. I mean, there is a number of others, but I think that one is, as it shares a different aspect, it's a pretty important one.
Yeah, I spoke to the Space Generation Congress a couple of days ago, and I was talking about suborbital launch and reusability. But all the questions that came back from the next generation were about sustainability. Like everything, I guess I should have been prepared for that. I really wasn't thinking that was going to be the focus of the conversation. When they're talking about the sustainability, when they're talking about the future, the next generation folks that I talk to, they always are thinking about a set of priorities. What do you think is the highest priority? If you were to speak to the next generation, the young generation that's coming along, what's the highest priority for you in terms of sustainability, climate change, and how we address small satellites? I put her on the spot.
Wow, all right. The highest priority. I think it's about getting to actionable information as quickly as we can. And I know our partners internationally and in industry are really moving with urgency toward that goal, right? It's for many years we did the science almost for the sake of science itself. And today there's a real urgency to accomplish that science for the purpose of supporting good decisions on both sides of the climate balance equation, right? The greenhouse gas emissions side, but also the balance of that. The how do we make good decisions about stewarding the Earth such that it can help us take care of this problem, right? So it's getting to that actionable information and doing so with urgency and with clarity, getting to information that is well understood, of clear quality, and usability.
Robbie, is there a highest priority that you guys are looking to address, or is that by the way, is it demand focused, or you're a company, obviously, trying to make your way, be profitable? Do they line up the highest priority for maybe what is climate change and what would be planet's highest priority?
So I would say biodiversity. When we talk about climate change, it's really a climate crisis, and we're undergoing a mass extinction right now. I think what you said about local communities is the right thing, right? More extreme weather, droughts, but then also the plants around us are changing, and the animals around us are changing. That's happening way faster than this number of 1.5C. We are terraforming our planet. Since the first V2 rocket camera was put on the V2 rocket, we've tripled the population of our planet, and we aren't thinking about it for future generations, and I think that rightly so, the next generation is seeing this. They are growing up in extreme weather. They are growing up with wicked problems, and it's almost as if we're kind of okay with it. But it's hard to see accelerating change. Everything seems linear, but we are in a time of accelerating change. So, for me, knowing space and knowing data, we always choose our mission with a Venn diagram overlap between what can be really good for science or sustainability. So that's one piece. The other is what's good for national security. And the reason why that needs to be there is because we can't jeopardize people's national security too much. So we don't want to get too far into only national security because we are an unclassified commercial company by design. And the third is what is a business model that we can do. And then that bullseye between science, commerce, and national security is where we define a mission. And to look for where is a missing data gap that's necessary to get to actionable information. And there's a project that we are so proud to be a part of called Carbon Mapper, which gets at empirical measurements of greenhouse gas emissions, both methane and CO2, but it really is a biodiversity mission. It's an imaging spectrometer that goes 420 different spectral bands. And this is something that is a deep partnership with NASA JPL, academic universities, as well, this is what I'm most excited about, regulatory bodies in government. If we know how long it takes to do rulemaking, then we can start that process so that by the time enhanced data become available, that is scientifically valid, that is super accurate and explicit, then governments can use these data sets to regulate some of these societal externalities. And at first, I'm an advocate for carrots. So, hey, we have this challenge. Let's fix it. And but you also say in a few years, by the way, we're going to fine you if you don't. And being able to make the invisible visible is something that our community can do in Earth observation by measuring point source CO2 emissions, for instance, so that you can attribute emissions to the well or to the waste treatment facility or to the agriculture feedlot. A lot of people just don't know it's there. If you make it available, people will, sometimes it's a loss of product in the energy sector. So people will want to fix that. And other times, we inadvertently have this negative externality that we probably need to change how that business is done.
It was interesting in preparation for this panel. Just on October the 19th, I had sent around a story from the Wall Street Journal that was right on to this point, whereas using satellites, polluters can't hide anymore. They can see where this methane emission is coming. They can see, not that we all want to be the police force of the world, but it absolutely can drive and have an impact on what's happening on Earth by being able to, basically make this awareness. Right? So Germany unfortunately had some very extreme weather events this year, some tragic flooding.
Yeah.
Is this one of the high priorities, the topics to understand that better for
Yeah,
you?
yeah. Actually, we have been very strong in disaster control and imaging, and we have established a center for that issue and have been working on that for many years. I'm not really thinking that might occur in Germany, so it has been, I think, of use to a number of nations and people, but we really had to use it this year. That was really tragic, and we were pretty happy that we also had the facilities in place to do to use airplanes and helicopters to get a complete view on the disaster and to be able to mitigate it as best as possible. I mean, it was really tragic also for the DLR staff, because we had a lot of people who live in that area, and we have seen that sometimes benefit as is, it's also quite helpful for yourself. So that was a lesson we learned. Yeah, we think also that in fact small satellites will be of huge benefit for climate impact mitigation also in a number of other aspects. So I'm looking at coastal regions and we think that our knowledge about how to look at the situation and such a kind of disaster is going to be helpful also in a number of other events.
Thank you. So I'm going to shift a little bit from the planet to space. My favorite word that I saw last night was LEO ecosystem. It just kind of rolls off the tongue. It's just fun to say. You know, a number of the questions we have from the audience here is how many satellites can be up there? Is there a problem with potential conjunction? You know, with it? How do we have a healthy ecosystem for these constellations of small satellites? So, Robbie, you want to take a crack at that one?
Yeah. So I think 2020's space will be about space infrastructure and interoperability across infrastructure that's there. So, for instance, instead of having the satellite take everything with them, like huge amounts of comms and a huge amount of other stuff, you can then tie into commercial infrastructure. So, space, ISL, inter-satellite links, I think is people need to be thinking about that for all future missions. And that's awesome because it decreases the cost for new missions because you can tap into that infrastructure. And inter-satellite links is super useful because then you have real-time connection to your sensor in space. And if things where minutes matter for saving lives for a flood, for instance, you can have that information sent immediately to communities and first responders that need it the most. So I think that is going to be game-changing for 2020s and changing space architecture. The second thing I would say is that space is a commons. And we as a community need to design our missions from cradle to grave. So whether you are a commercial business or you are a government, it is the responsibility of the actor of making sure that you don't leave garbage, and that you whether it's contract with companies in order to have a service to pull them out of space if they're not in a super low Earth orbit, or propulsion itself in order to pull it down toward the end of life. But that's absolutely critical for any responsible actor. Then the other thing I would say is it's time for us to be more transparent in space. Most of the space infrastructure still has a lot of architecture from a 20th century architecture, which is a classified first architecture from the national security community. We know where those big satellites are; everyone can see them. And I think it's time for an open space situational awareness to then allow for there to be more of a space traffic management, which is very similar to air traffic management, so that we have freedom of flight, not just for the planet. So that's a change. I think it must happen this decade. How quickly it will happen is still to be determined, but the cat's out of the bag for this transparency, and for those who care about broader rules-based society, having openness and transparency is necessary for us to then not pollute the space environment, and to be responsible actors in space. So it's a concern. Don't get me wrong, space debris is a concern, especially from the activities of the 60s and 70s in low Earth orbit that are around 750 to 1,200 kilometers. There's a bunch of dead satellites and upper stages that are up there. And that was primarily done by the Soviets and the Americans. I do think that we have the responsibility of taking some of the big ones down so that it doesn't accelerate the Kessler syndrome. But for all new rockets, upper stages need to be deorbited. And that is largely the case right now today. For all new missions, they need to be designed for demise.
Karen, Anka, do you want to care to, where's that? He covered it well.
I think he Robbie covered all the key points that I would have raised as well. So.
Actually, I think that the space debris issue, credit issue, is something which the younger generation will be very keen on. I mean, you learn it from a lot of other industries, and I think that's going to be a critical point, actually, also for small satellites.
Okay, one of the questions here, maybe I'm not the expert here, will there be a successor to the TerraSAR tandem mission providing equally quantitative data for measuring the Earth's surface changes, glaciers, architecture?
So we hope so, we very much hope so, but that's not a technical issue, so we have all the scientific ideas, we have the design, basically we have everything we need, except that it costs a lot of money.
Robbie, maybe another question from the audience here. Is there a technical barrier that prevents small satellites from monitoring specific climate aspects, wavelengths, accuracy, field of view, aperture?
Yes, is the long and short of it. You can do many things in small packages, and in some cases it's way harder. But when it comes to spatial resolution, that is really based on optics, and then that needs to be much bigger. So there are some things that you can do, like fly lower. Great, you can maybe get 2x better than traditional concept of operations or where satellites used to operate. So that's cool. So new technology coming in, allowing for you to get 2x better. But when it does come to the spatial resolution, you typically need to have either a lot of power for radar, right? Or you need to have a large optic in order to make that possible. It's a fun, fascinating trade, right? We in the space sector, we are systems engineers at heart, and it's kind of fun because the trade space is opened up now, but still physics you can't get around.
So I think it's something like 90% of Earth observation satellites are in polar sun-synchronous orbits. Are there other orbits that we're looking at to take advantage of? Are there other things that we can do to increase this kind of data set that we talked about earlier?
Yeah, you're right. Most of the observations we make are in polar orbit, particularly important for climate, because of course the polar orbits are global, right? They see the entire system. That said, I do think we're going to see some capabilities in geostationary orbit that will be potentially significant contributors. Even today, some of the NOAA and EUMETSAT geostationary satellites do contribute to our understanding of not just climate change itself, but again how it plays out. And I think we may see, well, for example, we've got the GeoClarb mission on the horizon, which will be a geostationary, and looking at the Americas in terms of carbon sinks and sources. So again, both sides of that equation. So yeah, I think geostationary will become, for some measurements, a very important orbit for us.
Anything in mid-inclination, excuse me? Robbie, are you guys looking at mid-inclination or no?
Yeah. So in polar orbit, you can get globally. Also, sun-synchronous orbit is super cool, right? Just the way the orbital dynamics work is that the satellite passes over at the same local time everywhere, and that's really neat for consistent observations. If you want that every 16 days, or every 4 days, or every day, or even every hour, you put them in different inclinations. So polar is really key. It's also consistent when it comes to power generation capability, but yeah, when you come to more mid-inclination, then you pass over at different times per day. You don't get global coverage, but you can increase your temporal frequency. And for areas that, especially where humans are, then yeah, coming down to like a 40-degree or 50-degree inclined orbit kind of similar to where the International Space Station is, then that's where the majority of human population is. Inclined orbits increase the temporal and different crossing times of collections.
Absolutely, and I'll just add also, there are certain processes that are important for climate change that are very much tropical in nature, right? Really, the phenomenology you want to observe is in those lower latitudes, and so in that case, it also makes sense to go with that, those lower inclinations.
And in fact, I don't know if we have the planet animation video, but I can actually show these exact two things in there.
Do we have that in the back? Can we put that up? I don't know if we...
So we have two constellations in space. One is in that polar sun synchronous orbit that creates a virtual line scanner for the planet, so everywhere, every day. And then we have 21 of the high-resolution satellites. 16 are in sun synchronous orbit, morning and afternoon crossing time. And then 6 are in an inclined orbit. And what that means is that our users can image up to 10 to 12 times per day. I guess we're not able to see it, but yeah, it might be later on in the slide deck, the next one if you can.
Some beautiful images nonetheless.
Well,
Which were these? Can you describe which
so
of your
this
spacecraft
is the planet scope. This is a SkySat. So the one before is imaging the whole world every day at that spatial resolution, and this one is a rapid revisit capability, so multiple times per day. So if an event happens, like in this case, it was an oil tanker, you can then get up to 10 collections per day, so that you can really understand something that is happening really fast. Let's see if the next slide actually shows this. But these are some animations that this also comes from imaging the whole world every day. A quarter of the world's population, of the Earth's surface, is really focused on agriculture. When you have that frequent collection of what's happening, and you can see into the near infrared, then you can understand what's happening with respect to crop productivity. I think we can move on.
Okay. Well, we only have a few minutes here, so just summary thoughts. Anything takeaways you would like the audience to have? Anka, you want to start?
Yeah, actually, we think that there is an important issue still in the verification of climate models based on a global and regional scale, where small-scale satellites can be of a huge benefit. And we also think that it's really important to couple the satellite data also with observations by other means. So, for instance, by airplanes, or also by many other possibilities we have. And we already talked about open data and about coupling the data. We think that's an incredibly important issue. And to make that available, the really local data for a number of businesses. It's said agriculture a number of times. I think smart farming is becoming more and more important, and I think that's also becomes more and more important to make people aware of the new possibilities, and that's going to take quite some time, I think, particularly in agriculture, but I guess also in other kinds of tasks. And we also think that it's going to be a huge possibility for new companies to come into the market, for new services to be provided, and that we also have to see that we get a good industrial ecosystem to really make the best of the chances and opportunities we're going to have.
Thank you. Robbie, any final thoughts?
This is an ecosystem, and it's a partnership. We are in a planetary crisis. And I do think that it is really all about building products and services to get it out of the space sector, out of our community, into hands of policymakers, into business leaders, and into community leaders. It's really exciting in the Earth observation space because it's now tapping into a lot more of society that then can be part of how we become better stewards of the planet. But There's a bit of no time to waste on this. COP starts next week. We have 9 more years left of the Sustainable Development Goals. 14 of the 17 SDGs. Our sector and Earth observation can help to measure, report, and verify, get people on a common operating picture. This is a crisis. Our community can help in a small way, but have a huge impact. And it's going to take, kind of deep partnerships and uncomfortableness in figuring it out together. But we as a community, I think that it's our responsibility to do that.
Okay.
All right. When we talk about climate change, and it is a crisis, it's easy to despair. And I think my parting message would be the biggest uncertainty in both how rapidly the climate will continue to change and how well positioned mankind will be to manage the changes that come. The biggest source of uncertainty there is the decisions that humans will make. And there is an enormous range between the best possible outcomes and the worst possible outcomes. And it's going to take all of us contributing to the good decision making. And so we need to keep innovating. We need to keep turning our observations into information, and we need to keep finding ways to make that information accessible to all of the folks who have decisions to make. Thanks.
Thank you. Please join me in thanking our panelists, Anka Kaiser-Pazal, Bobby Schenker, and Tiffany. Thank you so much for the conversation.
Thank you.